Aloha, Richard Halverson here. This is ICS321, and today is June 9th. And so let me share my screen. All right, so here we are. I want to take a look, and we see that the first, if we look at the playlist at the videos, there's 5 videos up there, and I'm pretty sure that nobody has watched video number 4 yet. Okay, I made video 4 and video 5 on Monday. It was today's Wednesday. Monday I made video 4 and video 5, and everyone has, and lots of people have seen video 5, but no one has watched video 4. And I believe that is because people don't realize that there's a video 4 there, because I uploaded them like at the same time, you know. So anyway, just you know, if you might not need to watch it because it's sections 2.5, 2.6, 2.7, and you may be good at. I'm not talking about you, Taryn. I'm talking about everybody else who's out there watching. That you know, is just going to see this later today. So I wanted to point that out to you folks later today. But anyway, so we're back here. We're gonna do video number 6 today. Today we're gonna do video number 6. Okay, so and what is video number 6? Let's see. Today is June 9th, which means we're in this section. So we're gonna start chapter 3. All right. So if we go to chapter 3. Chapter 3, database design. Okay, so next we're gonna, you know, in chapter 2 we learned about normal forms and relational algebra. Those are 2 very important things in database in creating in designing databases. That's very important for designing databases. Relational algebra is good for understanding what can actually be accomplished with select statements, and then normal forms has to do with reducing your database into smaller normalized tables, more tables that are smaller, to reduce or hopefully eliminate redundancy. And when you eliminate redundancy, that means that there's a whole set of mistakes that cannot happen as you're maintaining your database. Entities, relationships, and attributes, which is in this chapter, we're starting this chapter. This has to do with another way to look at the design of databases. It's how to conceptualize a table as a relation, and then how they relate to each other, as far as when you're joining tables together. We have concept of one-to-one relationship, many-to-one relationship, many-to-many, and so on. So that's what we're going to go over today. And there's a diagramming method that we learn to help document databases as entity, a database as an entity relationship model. And this is pretty important for big databases. You know, like if you're going to do a database let's say for a restaurant, and you're keeping track of the wait people and the orders when they wait on a table, and the individuals at that table order their dishes and so on, and recording that information all the way back to the inventory of your spices. Okay, so there can be this can be a huge system, and and it can have related in a way where you know not to take an order if you don't have all the ingredients to fill the order, and so on. So anyway, let's get started. Okay, so an entity relationship model is a high-level representation of data requirements. Let's see what happens if I switch to this presentation mode. An entity is like a person or a place or a product or a concept or an activity. It kind of relates to what a record in a database table would be. And a relationship is a statement about two entities that we'll see, and an attribute is a descriptive property of an entity. So that's like a field. I don't like this presentation view. The model only includes entities, relationships, and attributes that are relevant to the database. Most of the time, these entities are single tables, but and a line between them. So this would represent two different tables. Sometimes, however, though, the line has to actually be implemented as a table. If you have a many-to-many relationship, as we'll see, we actually have to have another separate table in there to make the connection. In the supplier parts database that we did, that you do for the first assignment, we've got these parts, we've got this database of parts, this table of parts, we've got a table of suppliers, and then we also have this third table, which indicates the shipments of parts by suppliers. And so the entity relationship diagram would just be considering parts and suppliers, but the connection between them would be for suppliers who have parts and shipment. That would be a relationship between the attributes. So in this example, you have an airline reservation system, passenger and booking. A passenger and a booking are entities, and let's see, this is a participation activity. So we have a passenger and booking entities, and there's a relationship between passenger and booking, and passenger number, passenger name, booking code, booking costs are all attributes of the entities. All right. So an attribute is in an entity relationship. Attribute is used in both an entity relationship and relational models. Two different things. We talked about relational models in the last chapter. This chapter, it's entity relationship models, and the relational model attribute is a formal term for a column. And since entity relationship attributes typically become relational columns, the meaning of attribute is similar in both models. So what do the following requirements become in an entity relationship model? Okay, so we've got widgets and digits. The widgets and digits company has projects that are composed of multiple tasks. Tasks have multiple duration. Projects have multiple duration, tasks have a starting date, and so on. All projects in the company become an entity. Let's see what the answer is. Entity, yes. So you put entity here. Duration of project becomes a attribute. So this would be attribute. So you should go through this and make sure you understand what all these terms are. Relationship. All right. So we have an entity relationship diagram, commonly called an ER diagram. It's a schematic picture of entities, relationships, and attributes. Entities, relationships, and attributes are these. So this one, attribute. The duration of a project is an attribute. The starting date of a task is an attribute. So it's a field. It's going to be a field in a table. There's going to be a field which says how long the project is. There's a field that says what the starting date is, and so on. So here, let's go through this one. Interpreting an ER diagram. So an ER diagram for an airline reservation system has multiple entities and relationships, but no attributes. And each entity relationship is read following the direction of the relationship verb. Okay, so passenger makes a booking. So this is a relationship here. Passenger makes a booking, and a verb points to the right, and the verb arrives at points down. See, what is this now? Includes. So flight includes a booking. A flight arrives at an airport. The glossary, also known as a data dictionary or repository, documents additional detail in text form. It'll include names, synonyms, descriptions of entities, relationships, and attributes. For simple databases with few users, a database designer may record the glossary in a text editor, but for more complex databases, you should have some kind of software tool that helps you with that. So referring to the animation above, how is the schedules relationship read? Let's see. Airline schedules a flight, it looks like. Schedules a flight. So is it this one? Yes, it is. An entity relationship model is completely described by, I guess it's this. What is the glossary? Glossary includes names, synonyms, descriptions of entities, relationships, and attributes. Now, I don't. It's either this one or this. I'm gonna say this one. No, it's not. It must be that one. Okay. And this one, it says software tools for entity relationship modeling automatically generate the ER diagram. Okay, so the software generates the ER diagram. Are we using any tools that generate automatically? I guess we're not. I don't think we are. We aren't using any tools that actually generate these ER diagrams. Microsoft Access sort of does, but we aren't using that. All right, types and instances. An entity relationship modeling, a type is a set. An entity type is a set of things. So that's like the relation, or that's like all the records of a table. A relationship type is a statement about entity types. Employee manages department. An attribute type is a set of values. In other words, like for example, employee salaries. An instance of an element. An instance is an element of a set. So it would be like a single record. So it's like a single employee. A relationship instance is a statement about an entity. Like Maria Rodriguez manages sales. So this is about an instance of an attribute instance is, for example, if somebody makes $35,000, so that's an instance of an attribute. So it's like a field. It's like an existing field of an existing record. Entity relationship and attribute instances usually become rows, foreign keys and column values, respectively. So we have an entity type is a passenger, an entity instance is this person. Attribute type is like a booking code. It's a field, and this is an instance of one. This is a particular value in a field. And a relationship like this is passenger holds a booking, and in a specific instance of that is this individual here holds this. Does anybody remember the famous boxer Muhammad Ali? I don't think that's how you spelled his name, though. I'm just sidetracking here. M-A-H, oh, it is. Oh, no, it's E instead of A. Okay, I was just curious. Back in my day, you know, I'm old, he was a famous fighter. And then later on, I was at about 2 years ago, I was at this conference in Virginia, and it was for community college instructors, and we were learning about stuff, we're learning about diversity and inclusion in college classrooms, and there was a student, there was another instructor in the seminar. His name was Muhammad Ali, and so we were at dinner one night, and I asked him, so how many people tease you about your name, or ask you about your name, or make a crack about your name, and it's like nobody else at the table knew what I was talking about. I think they were all younger than me, and the guy said, "Oh, all the time." It's whatever. Anyway, it's interesting. Sam Snead was a famous golfer too. Okay, so match the term with to the example. Relationship type. Okay, this would be an instance. This would be Eleanor Rigby was you may remember the Beatles song, Eleanor Rigby.
Yeah.
So is a student that, is it this one? No. Do you know the answer?
I put an entity instance.
Yes. Okay. Right. Okay. So
the relationship instance
was this one?
Relationship instance was the takes final exam.
Oh, all students take exams. Is that what? Yeah. Oh, wait. You said it was this one.
Yeah.
It's an instance of, okay. So the relationship is Eleanor is the student in the exam, I guess, and the relationship is and this is just an instance of it. It's not a type of it. So
right. So students taking an exam would be a type, a relationship type.
Yes, very good. Okay, and then we've got.
And then students at the college, that's a type because it's a group.
Yes.
So entity type.
Yeah, okay.
So and Eleanor Rigby must be an
instance. Yes. This is an attribute, right? Okay. This must be an instance, and this must be the type. Yeah. Okay. All right.
Okay. Cool.
This is easy. This is this was this topic of entity relationship diagrams was a topic that I had the first database course I taught was over in Scheidler, their ITM 354, and we didn't cover entity relationship. The original instructor didn't cover entity relationship diagrams, and then when I taught the course, I included it because it's a pretty common thing to teach in database classes, And then in this class, in ICS 321, I continued to teach it, but I don't think the last professor who taught it before me taught entity relationship diagrams either. I don't recall his doing it. And I know that there's a couple of different ways of drawing entity relationship diagrams, and I'm not sure yet which one we're going to do in this textbook. But so it's not often covered by every in every database course. Just as relational algebra is not covered in every database course. Relational algebra is not covered in the database courses in the community colleges, but they are here. But anyway, both of these topics are important. And if you ever get a job and you're going to be working with databases, you know, in a software engineering capacity or something, you're very likely going to have to learn and use a version of entity relationship diagrams, whether you're drawing them originally because you're designing the database or because you're implementing the database that somebody else designed, or you may be one of the designers. All right, so database design, first we analyze and develop the entity relationship model. We usually do, if we're using entity relationship diagrams, we would do that first. And then we do a logical design, which converts entity relationship models into tables. And then the physical design, where you go in and throw in indexes, and this specifies how tables are organized on storage media. Okay, I don't think we even, this is left up to the, okay, let's see what this is. This seems to me, this here is also beyond what a database designer would do. This is sort of handled by the people that are designing the database management system. But let's see where this goes. Okay. So analysis is important for complex databases with many users. And now first we discover the entities, the relationships, and the attributes. Then we determine cardinality, and that's this many-to-one, one-to-one, you know, like an individual can take one class, or if you have students and classes to take, it would be one student can take many classes, and a class can be taken by many students. So that's like a many-to-many sort of relationship. So anyway, distinguish between independent and dependent entities. That's kind of important too. We'll learn about that. And then what supertype and subtype entities are, we'll learn about that. And then after, these are the analysis steps, and then design steps is where we implement the entities, implement the relationships as maybe additional tables, implement the attributes. I'm not sure what that gets us, but it could be like populating the table or defining the attributes probably. And then well, that would sort of come up here. Implementing the attributes, that might be the data types to use for the attributes, and then normalizing the tables, of course, is reducing them so you get rid of the redundancy. So analysis considers the details of the specific database. I think this is false, because it documents the database requirements without considering the implementation details. An entity relationship model is developed for all database projects. I don't think this is true, and it's only databases, simple databases, we don't really use them. And entity relationships and attributes always map directly to tables, foreign keys. Is this true?
It says
No.
it's false, yeah.
And the reason, oh, wait a minute. Oh, okay. Oh, sometimes an entity splits into several tables, or several entities merge into one table. Okay, yes, that is true. Yeah, okay, there are definitely examples. I can think of definitely examples of where an entity splits into several tables. Merging into one table, I guess that's possible. and relationships and attributes become tables.
Okay.
All right, what's next? Let's see how far we're going to go today. 1, 2, 3. Tomorrow's going to go over this. This is Wednesday. I'm teaching another class tomorrow, right?
Yes.
So I June 9th and June 12th is that day. So I should try to finish chapter 3 this week, which I should be able to do. Right? Oh wait, no. Wait a minute. 613 to 617. Oh, I get next week too. 613 to 617. Oh, good. So chapter 3 goes all the way to Thursday the 17th. Good. So I'm gonna so today I'll cover some of chapter 3. Tomorrow I'll cover this assignment, normalization assignment, and then next week I can do a chapter more on chapter 3.
Okay, cool.
All right, very good. Okay, let's do discovery, independent. Let's try to do up to 3.5. Okay, so for discovery, entities, relationships, and attributes are discovered in interviews and database users and managers. So users and managers are usually familiar with the data requirements of an old. So let's say you're redesigning the database for a customer, and the customer is, let's say you are working in a company, and your customer is also in the company, and you're on the database team, you're on the programming team that's going to redesign the database. And so what you do is you would interview the users and managers of the current database. The database, assuming that something is being replaced. Something would always be replaced unless it's a brand new company, I guess. But you may be replacing a bunch of spreadsheets with the database, so you might not even be, the old database might not even really be a data implemented in a database management system, but nonetheless, the concepts are the same. And we still have these entities, relationships, and attributes. We'll always have those. It's just if we're going to formally recognize them and write them down and go through the process of designing the database from the entities and relationships that we've discovered in these interviews. So when users are difficult to reach, a database designer may communicate through surrogates. Sure, a sales representative might communicate on behalf of prospective customers, I guess. Yeah, that makes sense. Entities usually appear as nouns, but not all nouns are entities. Designers should ignore nouns and denote specific data. Should ignore nouns that denote specific data or are not relevant to the database. Relationships are often expressed as verbs. Designers should ignore statements that are not about entities and not relevant to the database or redundant. And designers should also look for relationships that are not explicitly stated, since users may overlook important information. All right, so attributes are usually nouns denoting specific data, such as names, dates, quantities, monetary values, and so on. So entities are nouns. Attributes are nouns, and relationships are verbs. Okay. All right. We fly many flights in and out of airports. We track. So this is somebody's talking. We keep track of airport codes and addresses because we often ship airline parts direct to the airport. Each flight has up to 220 passengers, depending on the size of the aircraft. When a traveler makes a booking, we have to save the total cost because prices change all the time. And we record passenger name, credit card, and mileage, and the mileage plan number. Okay, so what are we supposed to do here? Let's start this up and see. We have many flights in and out of airports. We keep track of airport codes and addresses. So those are attributes of an airport. And because we ship plane aircraft, each flight has up to 220 passengers depending on the size of the aircraft. Anyway, let's keep on going here. And then we have airplane is another word for aircraft. Oh, okay. Traveler is another word for passenger. Oh, that's good. Usually address and credit card have many details and are entities. Further interviews determine the database does not track parts, even though we ship parts direct to airports. Okay, so anyway, okay, what's this one? Discover the relationships. Okay, this was discovering the entities, which are nouns. Next, we're going to discover relationships, which are verbs. So let's watch this, see what this one has. So we have, we fly, flights in and out of airports. So flights arrive at and depart from airports. The traveler makes a booking. This makes, okay, so those are relationships. And then each flight has up to 220 passengers. We often ship airplane parts to the airport, but we don't keep track of the shipment of parts. So that's information that we don't really use. Okay, because some may not be relevant to the database. Turns out parts is not relevant to our database. All right, and then discovering the attributes. Let's see what this does for us. Airport code, the total cost, and the name of the person, name of the passenger. These are all attributes. An airport code is an attribute of an airport. The total cost would be the booking attribute of the booking, and the name can be an attribute of the passenger. And the mileage number plan is an attribute of the passenger. Is that it? I guess so. All right. So which noun is an entity? Okay, our department tracks student information, which we record, which we have record of every course taken by students and the professor who taught the course. We also keep track of the name and number of credits for each course. For professors, we always store the name and the current title, such as assistant professor or visiting lecturer. All right, so which noun is an entity? I would guess that this is an entity. Which verb is a relationship? Taken. Taken. A student takes a course. Which noun is an attribute? The title would be an attribute. It's the title of the course. All right. Entity names are a singular noun. Relationship names have the form entity, verb, entity, such as division contains department. Okay, so it looks like the entities are usually Entity, verb, entity. Entity, okay, so division contains department. When related entities are obvious in ER diagrams or informal conversation, verb is sufficient, and the entity names can be omitted. A verb should be active rather than passive, manages rather than is managed by, and occasionally the same verb relates to different entity pairs, like order contains line item and division contains department. Okay, so contains is the verb, but it's applying to different entity pairs. Attribute names have the form entity qualifier type, so such as employee first name. So this is like it's like the name of the entity would be employees, and then the qualifier type. So this is an attribute of this entity. Yes. So entity is the name of an entity that the attribute describes. Right. When the entity is obvious, did I say that already? Qualifier describes the meaning of the attribute. First, last, alternate. Sometimes the qualifier is unnecessary and can be omitted. A type is chosen from a list of standard attribute types, such as name, number, count. These are attribute types are not identical to SQL types, but count might be an attribute type representing quantity, for example. Standard attribute types are documented in the glossary and applied uniformly to all attribute names. Formal name, vehicle relationship, vehicle belongs to, informal vehicle license number and license number. I see. Okay, so that's why you don't have to necessarily say the entity if it's obvious. Students is a correct entity name. So I wonder if should it be student? Is this true?
Yeah, it should be false because it should be student, like you said.
Should not be plural. Sure. Okay. License is the correct attribute name. Is that true?
They said false because it has to have a suffix.
Attribute. Oh, attribute. Oh, I'm talking about an attribute. Okay, so that would be a. It has to have a suffix. What is that?
So I guess license would be like the entity, and
then the suffix is the actual attribute that we're talking about. I see. Okay. Employee manages employee is a correct relationship name.
So they said this one's true, although I don't see when it would. I mean, I think it's kind of probably doesn't normally happen.
Let's see what it says when you say false. Sometimes relationships relate to the entity itself, since manages is the active form of manage. Employee manages employee is a correct relationship name. Yeah, okay. People is the correct entity name. Is that false?
Yes.
Because it should be person?
Yeah.
Okay. I'm getting it. Passenger mileage plan code. So go ahead.
Oh, they said true because if passenger is the entity, then the
And
mileage plan code
plan
is
code.
the attribute.
I get it. That's like your, is that like your Hawaiian miles number or something?
Oh, yeah.
Like, yeah.
Yeah, that
Okay, so,
thing.
yeah. Department is managed by employee. No, I guess not, because it shouldn't be is managed by, it should be manages. No. Oh, no.
Yeah.
Really? A department?
So it says you're correct. So it was false because it says employee manages department.
Oh, that's what it should be instead. Yeah.
Yes.
Okay. All right. Synonyms and descriptions. The often entity relationship and attribute names have synonyms. Representative may be a synonym. Yeah, sure. Synonyms are common in informal communications. To avoid confusion, an official name is selected for each entity, relationship, or attribute. Other names are documented in the glossary. Glossary also contains complete descriptions. Okay. So let's see what this does. Traveler is a synonym of passengers. We fly many flights. When the traveler, okay, that's great. So in the glossary, we'd have passenger and synonyms of traveler and customer. That makes sense. The entity description begins with a name and definition. Entity name, followed by examples and counter examples. Okay. All right, in-cabin pets. Okay, synonyms and descriptions. Must entity, relationship, and attribute synonyms follow naming conventions? Should synonyms?
It says no.
That's kind of what I'm thinking. No. Synonyms may help users map commonly used terms to official names. Synonyms should not reflect common usage. Should reflect common usage, not naming conventions. Okay. What is wrong with the following entity description? The difference between a course and a class is that a course refers to the catalog description, while the class is an individual offering of a class in a specific term. So what's wrong with the following entity description?
So there's
go ahead.
The description does not begin with an entity name, so they didn't like how they started with the word difference. They said the
Yeah, you know, the problem I have with this description is it's not clear what we're describing. Are we describing a course or a class?
Right.
So I guess it's this one, huh?
Yeah.
And it says, right.
Begins with a name.
Yeah.
Okay.
Okay. What's wrong with the following relationship description? Student takes course. Describes all course instances taken by a student instance. Student takes course. Description does not include. What is wrong with the following relationship description? Not use sentences. Description should begin with an entity name. A description.
So they're saying it's not descriptive enough, and so they were saying it does not include examples and counter examples.
Yes. Okay. All right. That makes sense.
Although I first selected does not use complete sentences, but then I guess that could be a complete sentence. I just.
Yeah. It does begin with an entity name. I see. All right. Okay. First step of the, you know, I've never designed a database starting with an entity relationship diagram. That could be my problem here. I've never worked on a big, huge database project. Well, I've worked on a big, huge database project, but it was all me. So I had the entity relationship diagram in my head. Believe me, I did. I wrote the code from that. But when you're working on a team, you got to do something like this because you don't know what's in everybody's head, and they might interpret things slightly differently, and then you can really run into problems, especially when you don't have this glossary thing here.
Okay.
All right. So first, although the step number suggests a sequence, database designers commonly move back and forth between the steps. Okay, so first we identify the entity relationships and attributes in interviews, draw the ER, list standard attribute types in the glossary, and then document the synonyms and descriptions and names and so on. All right, discovery is a step in which phase?
Analysis.
Must be analysis. Identification of entities and relationships and attribute precedes, means comes before documentation. I guess usually.
Yeah.
And standard attribute types are determined after the ER diagram is drawn, I guess usually.
Yes.
And the reason it's usually is because although sequence commonly move back and forth, and that's why it's usually, yeah. I'm just getting it straight in my head in case somebody asks me again. In case somebody who doesn't watch this video asks, and I gotta tell you, you're here, but lots of times students will ask us a question that's explained right directly in a video, and that's all right. I answer the question, and then I might tell them, if you'd like to hear more about this, you can go to this video. But I don't, I never scold anybody for some obvious answer that somebody else would say, well, if you just would have watched the video. So don't worry about that for me. Ask any question. And I'm talking to everybody else who's not, I'm talking to everybody that's going to watch this video later. Okay, now you're here, so you get first, you get your questions answered immediately. In fact, I get my questions answered from you in a lot of these cases. I can tell you've gone through this. So it's not like I have never seen this before, but it might have been a couple of semesters ago since I've taught this, because I don't think I actually dropped this part of the course. This part of the course was not in the original course description, so I actually dropped it for a while, and I'm glad it's back, because it is a pretty it's a pretty good technique to learn, especially if you are going to work on larger databases. Also, it's a good exercise to, if you're ever working on a project where even you're just maintaining a database. One thing you might want to do, if you are if you've been given the task of maintaining the database, and this is going to be your job for the foreseeable future, the first thing you might want to do is ask, are there any entity relationship diagrams for this database? And the answer probably would be no. And then what you might want to do is just undertake a project on your own to start creating this and drawing this up and drawing these entity relationship diagrams, and show your boss and so on, and that probably be pretty everybody would be pretty happy with that, I would guess. Okay, so let's do this one. Our shipping company operates a line of container ships. We know the number of containers each ship can hold. Each container is identified by an industry-wide code. Containers are brought to ships and taken from ships by specially designed trucks. We track the latitude and longitude of each truck and each ship. Each truck is identified by its own naming system. While in transit, each container is either on a ship or on a truck. For each container, we know the customer name. Okay. So what are the entities?
I got a different one, but I was thinking ship. Is that one and truck? And then I don't know. Let me.
Well, how about a customer? Is that an entity?
Yes. Yes.
Is a container an entity? Containers are brought to ships and taken from ships.
Yes, I think so.
Company just is not anything, right? And
No.
latitude would be an
attribute.
attribute. Okay. Well, we're doing this together. So. Okay, let's check this and see what we get. No.
Oh, okay. Wait. Ship, truck, and container. Okay.
Ship, truck, container, and why would okay, that's right. Customer is not really a customer is like an attribute of a container, isn't it?
Oh, okay.
Wouldn't that make sense? Because we aren't really dealing with customers. We're dealing with ships,
container.
Trucks, and containers.
Okay.
Is that what they are? Ships, yeah. All right, let's see what the next day they're gonna have us do it again. So.
Oh, another one. Each college
maintains data of colleges. So a database of colleges. So colleges would be an entity. Each college has a name and identification codes. Those would be attributes of the college. Each college has a number of departments. I guess departments would be should be an entity.
I think so.
Yeah, because the college has departments. Each department has a name, and so name and address and phone number would be attributes of the department. Each faculty member works in one of the departments. The database includes the name, rank, and of each faculty member. So faculty members are also entities. So we've got college, department, and faculty member. And okay, so let's see if that's right. College, faculty member, and department. Yeah.
Yay. Cool.
All right, let's do the next one. Our business, okay, this one's we're gonna do, this is relationships. Our business has a number of factories. Each factory has a name and address, those are attributes. Each factory makes several products, so that it makes something, that's the, making is relationship, is that right? Yeah?
Yeah, so makes.
Each product has an ID, a name, and a description. Those are attributes of the product. Many kinds of parts are used in manufacturing each product. Each kind of part is identified by a number. Okay, so I guess maybe parts are also entities because they got attributes. Each part has a bin number indicating where the part is stored. Okay, so the entities are factory, product, and part. Oh, good, it tells us already. Factory. Oh, because we've got a number of factories. I've got a number of products, and each product has a number of parts. What are the relationship?
Well, factory makes product is one.
Yes, factory makes product. Product contains part. Is that one? And business has factory.
I think. Oh wait.
Oh, is that it? Yeah, I guess so. It has a number of factories. Yeah.
Okay.
All right, let's check this. Oh. Factory makes product. That's one. And product contains part, but not business as factory. Oh, because we only have one business.
Oh, okay.
Yeah, so it's not a yeah, okay, let's do this again. Oh, now we're just doing the relation. Is this the same one? Except we're just doing the
Oops.
relationships?
It looks like the same one. Okay.
Okay, the entities are, but there's just a different set of. Okay, it's not business as factory. We know that's not the case. Product contains part, yes. No, business, no. Factory makes product, yes.
Yes.
Is that it? I think that may be it. Oops. All right.
Yeah.
Let's do the last one. And then, oh, it's 11:31. So this will be the
Okay.
last one. Our state maintains a database of colleges. Each college has a name and identification number. Okay, so colleges is an entity, name and identification number of attributes. Each college has a number of departments. Each department has a name, address, phone number, and mails. Each faculty member is per department. Okay, so college, department, and faculty member are entities. What are the attributes of each entity? Oh, this should be
Oh, this is a long one.
College name. Each college has a college name. Each department has a department name. Each college has a college code. A faculty member has a rank. Who has an address? Department has an address.
Okay.
Faculty name, telephone number. Let's see. Telephone number is department.
Department.
Yeah. Does that look good? I think so.
I think so.
Yeah. All right. Well, good. So we will we'll start again next time with Cardinality. I don't think it's going to take me a whole hour to cover the assignment. I'll probably do part of it because it's kind of a fun assignment.
Okay, great.
All right. So
Thank you
I
so
will.
much.
You're right. You're welcome. I will see you tomorrow. Maybe.
Yeah, great.
Take
Thank
care.
you.
Yeah,
See you.
bye.
Bye. Thank you.